Hello students, this is Indrani ma'am from SIP Rasayan. In this lecture, I am going to find out the products of the following reactions. Now see, acid catalyzed rearrangement of vicinal diol. Vicinal diol means OH groups are at adjacent carbon atoms, or you can say this is 1,2 diol. 2-oxo compound is known as Pinacol-Pinacolone rearrangement. Rearrangement. Pinacol-Pinacolone. This is Pinacol. After the reaction, whatever product we are getting, it is Pinacolone. And here for reagent, you can use dilute or moderately concentrated sulfuric acid. Dilute or moderately concentrated sulfuric acid. Now we should know the mechanism. At the first step, what is happening? Protonation is taking place here. Oxygen lone pair is donated to H+, we are getting OH2+. This step is reversible. Then what will happen? Removal of water is taking place. So what we will get here? CH3, CH3, here OH, here CH3, CH3 and here carbocation. We are getting this carbocation. Then what will happen? Migration of this methyl group with its bonding electron is taking place to adjacent carbocation. So this is 1,2 methyl shift. 1,2 means from one position it is going at position 2. So what will happen? If this group is migrating with bonding electron, this carbon will become positively charged. And here it is coming at this carbon. So here CH3 we are getting. Now see, here incomplete octet is there for this carbocation. So lone pair will be donated here. And more stable resonating structure we will get this one. CH3, C double bond OH plus CH3, CH3. This is more stable resonating structure because here octet is completed. Then what will happen? Removal of H plus will give the ketone. Pinacolone we are getting. See, this is symmetrical molecule, so any one OH lone pair can be donated to H plus. But if here different groups are present, then two things you have to remember. I will explain one by one. And remember this step where removal of water is giving carbocation. This is rate determining step of this reaction. Now when different groups are present on carbon atom having the hydroxyl groups, you have to decide which of the two OH groups will be protonated. Remember, you have to protonate that OH which produces the more stable carbocation after removal of water. When different groups are present on the carbon atom having the hydroxyl groups, another thing you have to remember which of the groups will migrate. Migratory preference or migratory aptitude order is this one. Means if you are having hydrogen and phenyl, both the groups, migratory preference of hydrogen is more than phenyl. And if migrating group is having benzene ring, then the benzene ring which is having electron releasing substituent will migrate preferentially. Now see, here benzene ring is having OCH3 group which is electron releasing by plus M effect. So for group having benzene ring, you have to see electron donating ability. So this is having electron donating ability most here. So this is having highest preference. Then this is electron releasing by hyperconjugative and inductive effect. So then this one, and here Cl is having minus I effect. This is hyperconjugative and plus I effect. This is by minus I effect. This will withdraw electron density from the ring. So this is having lowest migratory preference. Benzene ring, unsubstituted benzene is having more migratory preference than this chloro substituted one. You have to remember all those things. Now we will solve problems one by one. Now take first example. This OH will react first with H plus because after protonation and by removal of water we are getting carbocation which is stabilized by adjacent benzene ring. If this OH reacts with this H plus, here protonation takes place and after removal of water, whatever carbocation we are getting, that is less stable than this carbocation. Then what is happening from adjacent carbon? This hydride is shifting. It is shifting. It is at 1. It is shifting at position 2. At adjacent carbocation it is shifting. So this is called 1,2 hydride shift. Why H is shifting? Why methyl is not shifting? Because migratory preference of H is more than methyl. So after migration we are getting this. Then draw more stable resonating structure and then by removal of H plus you will get this ketone. This is your product. Now for next problem, see this is vicinal diol, means 1,2 diol. In presence of H plus, Pinacol-Pinacolone rearrangement will take place. Now you have to decide which of the two OH will be protonated. Now see, protonation takes place here because after protonation by removal of water we will get this tertiary carbocation. So this is more stable one. So hydrogen with its bonding electron will migrate here. So after migration we will get this. This is more stable resonating structure and by removal of H plus we will get aldehyde here. So this is your product. Now see, this is also vicinal 1,2 diol. So in presence of H plus protonation will take place. Both the carbons are symmetrical. So at any OH you can show protonation. After removal of water we will get this carbocation. So here you have to decide migratory aptitude. So we know migratory aptitude of phenyl is more than CH3. So phenyl group with its bonding electron will migrate here. So after migration of this we will get this carbocation. This is more resonance stabilized structure. By removal of H plus we will get this ketone. So this is your product. Now see, for this example, this OH will be protonated. By removal of water we will get this carbocation. This carbocation is stabilized by resonance with two benzene rings. Here migration of this methyl group with its bonding electron takes place. Then by removal of H plus we will get this ketone. For this example, this OH will be protonated because after removal of water we will get this carbocation which is stabilized by resonance with benzene ring and also it is stabilized by inductive effect and hyperconjugative effect of this methyl group. If protonation takes place at this OH, then whatever carbocation we get after removal of water is less stable than this one. Now see, adjacent to this carbocation, this carbon is there and with this carbon ethyl and methyl group is there. We have seen migratory aptitude or migratory preference of 1 degree carbon atom is more than methyl group. So ethyl group with its bonding electron will migrate and we will get this carbocation, and from this carbocation by removal of H plus we will get this ketone. Now for this example, see, with this carbon 1 benzene ring and paramethoxybenzene is present. Here also same thing. So protonation can take place at any OH and by removal of water we will get this carbocation. Now we have seen that migratory aptitude of this group is more than this group because due to plus M effect of this methoxy group, electron density on this benzene ring increases. Therefore migratory aptitude of this group is more than benzene. So it will migrate here. So after 1,2 migration we will get this carbocation. Then by removal of H plus we will get this final product. In this video till this, if you like, please subscribe. Thank you for watching.